Okay. So, ball thrown upward comes back down. Ball is thrown straight up and falls back down to the same height. A student makes this graph of the speed of the ball as a function of time. What is if anything, is wrong with the student's graph? If something is wrong, explain. Okay. So a couple things will come out. When I see a graph, once again, check to see what's it talking speed. Now notice this is speed. So speed does not care about what direction you're moving in. So keep that in mind. That means speed will always be positive. So whereas you could have a velocity that's a graph versus time that has negative, this line right here, you will never have a speed graph go below that line. Because speed has to, by its definition, has to be positive. Even if the object does have a negative velocity, speed doesn't care about that. Just, I don't care what direction you're moving, how fast you're going. But does this make, let's start with this to begin with. In this graph, if I didn't even know what it was about, it isn't, all I know is that it's an object moving up and down, and we're going to say up is positive. So at the beginning, it is moving, correct? Mm-hmm. It has a velocity that isn't zero. It is a positive velocity. Because it's speed, so it's going to have to be positive. So, but if they say it's thrown straight up, this makes sense. It's got a velocity. As it moves upward, it slows down. Mm-hmm. Is that what this is doing? All right? So its velocity, slowing down means your velocity is getting less. And by the way, that would mean your velocity would be positive, and the acceleration that gravity is producing is negative. They're opposite directions. The object slows down. So what happens at this point? Well, what's its velocity at this point? Take a look at that line right there. What line is that? Along the axis is the zero line, right? So what's its velocity right then, or speed? Zero. Okay. That is actually the point, at the highest point at which it stops. Because when you throw something straight up, at some point, before it can come back down, it has to actually stop. It loses all of its velocity, all of its speed in this case. Now, then an object, because remember this physics has to deal with real world, so then the object's going to start falling back down, and as it falls, it will pick up velocity, it'll pick up speed actually, we'll say. Now, if this was a velocity versus time graph, this line, that line would just keep going like this, because now it would have a negative velocity. But this is a speed versus time graph. It goes back up. Does that mean, so we're interpreting that is now it's speeding up. Well, that's because its velocity, now that it's going down, is negative, and so is its acceleration. Oh, okay. And therefore, if they're together, speeding up. All right? Yeah. And the speed graph isn't going to show us that it's negative, that the speed is actually, the velocity is actually negative. It's just going to say this is what your speed is. So I'm pretty good with this on all counts. This shows an object that has a velocity or speed, it loses it all at the same rate, and then gains it all back again. And by the time it gets, this time it should be about right back where it came from. All right.